Before I really get started, I want to give a special thanks to chess.com. They're Gradle Enterprise users and have graciously permitted us to use their builds as examples in this presentation. It's great to be able to use a real-world, non-trivial example in these slides. And I'll talk more about how that project is configured as I get into real examples. Of course, as we all know, perf matters. Imagine you have a typical small Android team of about 10 developers. Each one of them does 50 builds per day. If those builds on average take 60 seconds longer than they need to, that's an entire developer day per day wasted building your app. And the real cost is probably higher. If your build takes too long, you mentally check out, you're browsing Reddit, you're making new Slack emojis. And as important as those things are, there are probably things your team would rather you be doing. So perf really does matter. Before I go into the individual parts of how you can improve your builds, I want to provide some general advice. First, don't just start making changes to your project and then running random Gradle tasks to see what happens. Think of it more like a science experiment and use the scientific method. Figure out the exact scenario or scenarios that you're interested in. Formulate hypotheses, design your experiment, run it, and observe the results. Maybe you want to speed up the iteration time while changing code in your app module. Or how long does an incremental build take with the change of a single line of code? This is actually really easy to model with the Gradle Profiler tool. We're all developers here. Let's be honest. We don't want to waste time doing things manually. We want to automate things. And this is why we built this small tool, Gradle Profiler. It lets you programmatically define the scenarios that you care about. With it, you can define your scenarios, run them, and then have the profiler collect statistics that you can draw reasonable conclusions from. So you might want to have a configuration scenario as a reasonable approximation for how long an IDE sync ought to take, or see what benefit you might glean from enabling or disabling various Gradle features. Here I've included an example invocation of the tool and some sample scenarios. This is literally a file you'd put in your project, or anywhere really on your file system. I'd recommend running this at night though, because depending on how pathological your build might be, this could take a long time. Each one of these scenarios would run about 10 or 15 times, and it gives you like statistics on how long it takes, like means and standard deviation, that sort of thing. In addition to that benchmark flag, you could have any number of profilers run. Whatever your favorite profiler is, we probably support it. It's very easy to do this. Definitely take a look at the GitHub repo. It has really good documentation. And of course, before you start diving into the deep end on any of this stuff, it is always worth the time to update your tools. Take a moment and ensure you're on the latest version of Gradle and the Android Gradle plugin. It's funny I'm saying this because that is out of date as of about 2 hours ago. We just released Gradle 4.10. So, and with that, it has an improved incremental compiler. It has, what else? Oh, Kotlin DSL 1.0 officially released with 4.10. So if you're into Kotlin, check it out. Yeah, so do that, and also make sure your Gradle plugin Android plugin is up to date. If you're on 2.x, you probably want to die, so make sure you're upgraded to 3.x at least. Briefly, I want to talk about JVM tuning. So I've seen this a lot on Stack Overflow, where someone says, paste these 20 arguments into your Gradle.properties file, and you'll be fine. You won't be fine. It doesn't work. Just don't do it. Just give the daemon enough heap space and leave the JVM to itself. It's already well optimized. And of course, that specific example of 4G is just an example. I have it on my computer. You might need 2 or 6 or 8, depending on what you're running. If you have IntelliJ and Android Studio and 100 Chrome tabs, you'll need more memory. But that's the only thing you should care about, unless you really know what you're doing. And here we have an example of a daemon that needs more heap space. Here we have nearly 17, point over here too. We have nearly 17 seconds spent in garbage collection, which is over 8% of build time in this instance. That's way too high, and I have seen higher. So you want that around 1 or 2%. So if this is your situation, give the daemon more memory, and you should be good to go. And by the way, this image is from a build scan, and I will tell you how to create one of those next. So earlier I was talking about using the scientific method for profiling your build. Let's say that you've done that. You have a bunch of builds, you think they're taking too long, and there's a problem. The question is, where is the problem? How do you investigate your performance issues? Well, there are several tools for this, but we do think that one of the most user-friendly and insightful is the build scan. Build scans are a persistent record of what has happened in a build, and they're shareable. You can easily paste a link to a colleague and say, hey, this was an incremental build and it took forever, or this build failed and I don't know why. Could you take a look? It's a great debugging and collaboration tool and also has a big focus on performance. Another benefit is that if you run into any weird issues, it's very easy to take that link and post a note on the Gradle forums, and then we can help you figure it out. It's one of the best things that you can send us. And we're always interested in helping you build better builds. And of course, build scans are completely free. If you've never used build scans before, it's very easy to create your first. Just run any build from the command line and add --scan. You can also add this to your build script if you want it permanently enabled, but this is a great way just to give it a try. And of course, today, we're going to focus on the performance aspect of build scans. Gradle has a very high theoretical performance, and of course, the Android plugin is also highly optimized for the most part. So we think that if we can get you closer to that theoretical limit, that's a great outcome. But of course, Gradle is also very flexible, so it's really easy to shoot yourself in the foot. So here are some red flags you should be looking out for. If startup takes more than 1 second, you have a problem. If a single line change takes as long as a clean build, something is definitely terribly wrong, and, or maybe you're just using Dagger. Another very easy benchmark is no change at all. You run assemble debug, you run it again. That should take almost no time on the second try. And of course, high garbage collection time. I already showed you an example of that, but in addition, maybe you're using a plugin with a memory leak, or maybe you're running lint too often. These are things that build scans can actually show you. Now I'm going to talk about your build step by step. The first part of the build is startup, compiling anything you might have in buildSrc, and also evaluating your settings file. And my advice here is short and sweet. You want to use the daemon. You want to make sure it's healthy and that you're not restarting it all the time. The longer it runs, the better and faster your builds get. Since Gradle is based on the JVM, it needs to be just-in-time compiled. So as you run more builds, the Gradle code gets more and more efficient at processing your code. We have in-memory caches, lots of them, and they help us to avoid all kinds of file I/O. So if you're not using the daemon, you're paying a huge price. But of course, the daemon's been enabled by default since Gradle 3.0, so you'd have to be disabling it explicitly, which people do. Don't do that. You've been warned. There are some pathologies that I've seen in the settings file. For example, rather than listing all subprojects explicitly, you might be tempted to do like a tree search for files ending in .gradle and say, these are my subprojects. That might seem convenient, but it's also hugely inefficient. And if you have a poorly written search algorithm, you don't want to scan your whole project for these files. And by the way, the code is total nonsense. It doesn't work. Don't even try it. There's not much more to say on this topic, so I'll move on. Configuration time. Configuration time, it's much more interesting. A lot of things can go wrong here, and they do. First of all, what is it? It's applying plugins, it's evaluating your build scripts, it's running your after evaluate blocks. All these get run with every single build. Running any task, even syncing Android Studio. So if configuration takes 10 seconds, every single one of your builds takes 10 seconds, even a no-op build. So you really want that to be as low as humanly possible. And I'll show you a couple of examples of how that can get out of hand. One of the most common things you'll see is resolving dependencies during configuration. This is bad because when you're not building anything, you're just running a help task or syncing Android Studio, you almost certainly don't need any of those dependencies. So why are you resolving them? The number here should be 0. Now, this is kind of a toy example, but it lets me illustrate an important point. Gradle configures tasks eagerly. It may look like it should be lazy because it's inside of a closure, but everything in here happens during configuration. This is actually something that we're working on, and I may talk about it more later if I have time, but just know that for now, everything in this block is eager. In particular, this collect call is eager. To properly configure the task, you're forcing Gradle to look up all those files so we can call collect on them. That means it has to resolve all that configuration's dependencies, which can involve network I/O. Luckily, these kinds of things are very easy to fix. You can make them lazy by just wrapping them in a callable. Now we're saying to Gradle, I depend on these, hey Gradle, I depend on these compile dependencies when I run, and when I run, given to me, but not before. Fortunately, we do plan on making this completely illegal in the future. So at some point, your builds will just fail if you try to do that. You're welcome. Fail fast, right? Another problem is inefficient plugins. Plugins that do expensive operations or expensive computations during configuration. You don't want to do network requests during configuration. Do you remember one time, I don't recall which project, saw a plugin that asked, am I in China? The code was, let's ping Twitter, and if we don't get a response, then we're in China. The problem was they got the URL wrong, and there was a 30-second timeout. So every single build, they had a 30-second wait, and then they decided we're in China. And then they set the mirror to China, and every developer around the world was hitting the China mirror. So don't do that. Rather than doing something like that, use a property. Have your users set a system property, use a property, and that'll be much more efficient. Another issue is plugins that do expensive computations. Necessarily so in some cases, but you shouldn't do it too often. One thing that I'll see is a plugin that computes some kind of version from Git, for instance. The script plugin just polls Git and sets the output as your version. This is fine, but then you apply this plugin to every single sub-project, which means it has to run with every project. So here what we've done instead is we apply the plugin only to the root project, and then we push the value into the sub-projects. So we only have to do that one time. And in the future, we plan to have an improved way of doing this. We're going to model it as a build property that can be computed lazily. But for now, this is safe and it's the way to do it. There's one more thing to consider for build configuration. As you all know, all of our apps come with 2 configs right out of the box, debug and release. On top of that, we can have flavors. We can have multi-dimensional flavors. And when we combine these concepts, we can have a variant explosion, right? I once saw a project with over 100 flavors. Just imagine how many variants that is. And the Android plugin has to configure all of them eagerly during configuration. Dozens, hundreds of tasks are created and configured for each of these variants, and you may not even use most of them. So in this example, let's imagine we have free and paid flavors. Obviously, you don't want to release a free version to your users, so we ignore that one. And that's a way to easily ignore many illogical variants, saving yourself configuration time. So that is configuration optimization in a nutshell. You avoid dependency resolution, avoid I/O, and don't repeat yourself, neither in code nor in build scripts. Let's talk about writing your own build logic. One thing you want to do is structure your build logic properly. Don't have just one massive script with hundreds or thousands of lines of ad hoc wiring, ad hoc tasks, lots of imperative code. One, it's a pain to read, and 2, it makes it hard to diagnose issues. And also, of course, your new hires will hate you. You should factor that logic out in the script plugins, as in this example. But even better, what we're moving towards more and more is extracting things into buildSrc. It has always been a recommendation to extract things into plugins and write proper Java classes for them, or Kotlin classes, or Groovy with compile static, because statically compiled things just run faster. It helps keep your scripts declarative, make your project configuration much easier to read and understand, and also with the Kotlin DSL, it's become even easier to do as a developer. The advantages, of course, is things are just run much faster. And if you've never heard of buildSrc, and I know many Android developers haven't used this, it is check out the link there. It's a great way to make your build better structured and more maintainable. And everything can be compiled statically, which improves build performance. So check out the link, good documentation. Now let's talk about execution time. This is when the tasks that you actually select are executed. For example, Gradle clean or Gradle assemble debug. And this includes syncing your IDE or running your app from the IDE. Obviously, it uses Gradle under the hood. There are several ways in which Gradle makes this process fast. It executes tasks incrementally, it caches task outputs, and it parallelizes tasks. And we'll look at each in turn. Sorry, Okay, incremental builds. As I said at the very beginning, if you didn't change anything and run the same task again, and anything whatsoever is executed, there's a problem. Here I have a timeline of a build scan from the chess project, and I was running assemble debug. I hadn't changed anything, I ran it again. And a lot of the project reran. 40 seconds is a lot of time to waste doing nothing. So what's going on here? If you have a build scan timeline like this, you can click on that and see any task and lots of information about it. So let's do it. Here we see the value for the input property version name has changed for the task generate, debug, build config. Now, even if you've never heard of that task, as I had never heard of that task, you can just read the name and know what it does. You can navigate to this trouble spot immediately. What we have here is someone decided that the version name should be time-stamped. Maybe they had a valid reason, but they didn't realize how bad of an idea this was from a developer build performance perspective. And because of this, every build is different. This completely destroys incremental builds. So just don't do it. Or if you must, do it only for release builds, not for dev builds. Another very common example is Crashlytics. As you might expect, the Fabric plugin needs a unique ID to enable it to identify each of your builds on the dashboard. By default, it will generate this unique ID for every single build, adding tens of seconds to your build time, because it basically invalidates a single file upon which many other tasks depend. In this example, I managed to make a 2-second no-op build take 25 seconds. Luckily for us, the build scan clearly shows the culprit. Even more luckily, it's a very easy fix. If you add the highlighted code to your build type and debug block, congratulations, you've shaved 20 seconds or more off your build time. And you can now add Gradle Build Ninja to your LinkedIn. But by the way, the Crashlytics team is aware of this. We've talked to them about it, and they're working on like a better solution. But this is completely safe, and it's one of the few times I would say copy and paste that code. Just do it, if you use Crashlytics, of course. All right. Gradle provides lots of ways to make compilation faster. We have, for instance, the concept of compile avoidance. For example, let's say you change a class in project A, and you only change a method body, some implementation detail that isn't exposed anywhere. If you have project B that depends on project A, project B will not need to be recompiled because none of the signatures in A have changed. So from B's perspective, there's nothing to recompile, and it's modularization that enables this. So modularize your apps. There's also incremental compilation. Within a source set, we can tell that you've changed this file or this upstream class. We can ask which other classes are affected by this, and then we can just recompile those. You've got class foo, bar extends foo, foo changes, bar is recompiled. Incremental compilation really benefits from nicely decoupled code. So if you have spaghetti where everything references everything else, you won't get any benefits from this. You probably don't deserve it either because you're a bad developer. There's one word of caution, unfortunately. At the moment, Kotlin annotation processing is a little slow. So when possible, try to use Kotlin language features instead of processors instead. And a good example of this is the auto value library. Many of you have used this, I think. I used that myself in a project not too long ago. But when I migrated to Kotlin, I could use data classes instead. And so it's one fewer annotation processor taking up my time. To give you numbers, we have a standard Java project with about 5 million lines of code. It takes 30 seconds for a clean build. You just add the kapt plugin, just add the plugin by itself, 50 seconds. So Kotlin annotation processing is a slow process. It's getting better, but just be aware of that. I'm not saying don't use them. Obviously, we all like those kind of things. It helps remove boilerplate code from our apps, but there's a price, and you should be aware of that. However, we are working on it. There's nothing inherently wrong about Kotlin that makes that so. It's just the tooling needs to mature more. And one tip I can give you right now for addressing that would be try to push code that uses kapt into its own module. So let's say you're using the room database from architectural components. Rather than having that in the app module, put it into the room module. Much smaller bit of code to process versus the entire universe of your app. That's a general guidance to give for any kind of processor like that. There is an elephant in the room. Whenever I say incremental compilation, someone says, well, but you deactivate it as soon as there's an annotation processor. And that is for a good reason. An annotation processor is just some piece of code. It's a plugin that runs in the compiler, and that, for all we know, it could be formatting your hard drive. So we can't just enable these things. But we knew we had to do something about it, so in Gradle 4.7, we added a feature called Incremental Annotation Processing. It's an opt-in for each processor author. It's just a set of rules that they need to adhere to. There's no new API. In fact, it's just one line of code in the resource file. So if they can determine that their library obeys certain rules that we define, then they can add that file, and then you get the magic back of incremental compilation. There are some early adopters like Project Lombok and Android State, but spoiler alert, Dagger is still not one of them. It is one of the most popular issues, though, on the Dagger GitHub page, so I would encourage all of you, go there after this talk and upvote it. Shame them into fixing that problem. Not much effort. Oh, okay. You should also take a look at this issue here and make sure that your favorite processor is on it, or tracking adoption of this in the Java and Android worlds. So if your processor is not on this list, just leave us a comment. We'll make sure it's on the list and that the author knows about this feature. I'm also happy to report that in the next several months, build scans will start reporting the amount of time spent doing this processing. We hope that you can use this information for making better decisions about what to add to your projects, and also maybe shame some library authors into changing their code, just a little bit. Let's move on to build caching. Caching is basically the next higher level where you can't run a task incrementally, either because you're in a clean workspace or you just switch branches in Git. We can still avoid running that task using the build cache. What it does is basically it computes a fingerprint for each task, and when it's going to rerun any cacheable task, it looks in the cache for that fingerprint, and if it finds it, it'll grab the output from the cache and then give it to you rather than rerunning the task, and that can save a lot of time. It's a very powerful technique, and it's so powerful, in fact, it made my prep for this talk a bit harder than I intended because I kept forgetting to turn it off. So I couldn't really show the improvements I meant to show in some of the slides until I remembered that. So really cool, you should definitely use that. Many tasks are cacheable. Tests can be cacheable. Let's say you've got a 10 module build, you ran it and CI is green. You change one submodule, you build it again. The 9 other modules that don't depend on this 10th module, they don't need to be recompiled. They don't even need to be rerun. Gradle will recognize that the inputs to those modules haven't changed, and rather than rerunning all the tests, give you the test reports for free, which is obviously a huge time saver potentially. For now, there are some complex tasks that have not been enabled for caching because the overhead is maybe too high in these cases. But we are working on them, and you can expect tasks like dexing and desugaring to be cacheable eventually. Now, I would be remiss if I didn't talk about remote caching. It's one thing to save time while developing locally, but imagine saving time across your entire team and CI infrastructure. In fact, imagine turning on your computer in the morning, pulling develop, and your first build of the day takes just a few seconds because someone else has already built it, and all the outputs are there in their remote cache. Remote caches are just wonderful, and you should be using them already. You can either install it yourself or use the one that comes bundled with Gradle Enterprise. I should also say that in some circumstances, the Android Gradle plugin from 2.3.0 enables a local cache by default, so it's possible you're already using it and aren't even aware of it. Let's talk about parallelism. Historically, Gradle comes with the -- parallel flag, and then what that does is it tells Gradle that it can assume it's safe to run tasks in different subprojects in parallel. It's a pretty reasonable assumption for most projects, but it's not strictly safe. For example, if you have multiple integration tests in different projects accessing the same shared database, you shouldn't do that anyway, perhaps, but if you do that, this won't work. They'll clobber each other. So you really have to know your project well before enabling this. But with that said, Gradle is working on something called the Worker API. I think there's going to be a lot of that in the next version of Android Gradle plugin. And that allows for truly safe parallel execution of tasks. Tasks would opt into this, and then they're completely isolated and cannot change any shared state. But with that warning out of the way, I nevertheless think it's worth doing now, and I'll show you some examples. This is what you'll see in a build scan if parallel is not enabled. You have just the one app module, and none of the tasks use a Worker API. In this build, task names have been redacted to protect the guilty. What we see is a highly linear build where practically all the tasks are run in series, and that would be a red flag. In this next build from the chess project, they had parallel enabled and 16 decoupled modules, and a lot of the tasks can run in parallel. And just to give you some more context, This is from a greenfield project replacing a very old code base that had about 350,000 lines of mostly Java code. The new project, this one, currently stands at about 115,000 lines of mostly Kotlin code, of which about half of that is in the app module. So it's not perfect, but I think we can all agree that this is better than one straight line extending to the infinite horizon. One thing to keep your eyes out for is improvements coming soon to the Android Gradle plugin. Right now, there are some Android tasks like resource merging that for now are not well parallelized. But the Android team is completely changing that pipeline, and it'll soon show much higher concurrency. This is back to my earlier point about always keeping your tools up to date. Okay, let's assume you've spent some time optimizing your build. How do you ensure it actually stays optimized? How do you find other issues you might not even know about? That's where Gradle Enterprise comes in. It's a tool that lets you see all the builds that have ever happened in your organization, not just on CI, but also locally. It's searchable, has a nice performance dashboard, and gives access to a lot of potential insights about how your team is building your apps. You can ask questions like, how long are builds taking? How long is configuration taking? What's the failure rate on CI versus local builds? We would expect a lot of failures for local builds, that's development, but probably not so many for CI. These are questions that we can investigate very easily with Gradle Enterprise. You can see what tasks people are running. Are they running clean too often? That's another red flag because it should not be necessary and can potentially waste a lot of time. Here I've run a search for all local builds where someone has requested clean. And one of our goals at Gradle is to make it so that you never, or almost never, have to run clean. If you do find any issues that only clean can fix, you have to just email me, tony@gradle.com. We are committed to helping you fix that. It also could be an education problem. People might remember being burned in the past when the builds were less stable, but things have really stabilized in the past couple of years. So avoid that. Avoid running clean. Of course, and for every one of those builds you saw on that list, you click on it and get deep insights we talked about earlier. And also you get a really cool performance dashboard. This is actually our own at Gradle from a few weeks ago. We were really worried about that spike and how everything sort of increased. Configuration time had gone up like crazy, and we were like, whoa, what happened here? It turned out that these were all from people converting their build scripts from Groovy to Kotlin. So that was actually an expected change. If you're changing all your build scripts, you're going to have to be recompiled. That's just natural. But in general, if you saw something like this on your dashboard, that might be a cause for alarm. And you could go in and dig and see what's happening. You can click on any one of those columns, and it goes to a build. We also have an export API. If you want to do your own custom analysis, you can set an alarm and post to Slack or something if you hit a metric that you care about. So this is how you can find out when something goes wrong and ensure that it stays right. Before I finish, I have a number of links here to guides that you should check out if you haven't already. I'm sure you'll learn things you don't know already. They're very useful. Optimizing builds is not a once and done thing. It's an ongoing concern. And finally, there's one thing you should take away from this talk. It's that go to scans.gradle.com, start using build scans for your project, see at a high level what's happening in your builds. We are constantly improving the build scan plugin, and so the future is bright. Thank you. Yeah, sure. I'm here for questions too. It depends on if they depend. Do they depend on each other? If they don't depend on each other, they should be able to run in parallel. If they don't, sure. The question is, will they be able to run in parallel, or they're going to run in series? And my answer would be, if the variants somehow depend on each other, then they're going to have to be run in series, but they shouldn't, right? Like if you should compile the one source set, and if multiple variants, they might have their own bits of code that only for that variant, but otherwise they should be able to run. They should be able to run in parallel. And if you have an example of that not happening, I'd love to see it. Yeah, you can email me and we'll talk about it.